Hello there, I'm Thomas, the pilot flying the Airbus A340 300 for this flight. I'm also flying the Boeing 737-800 and the Boeing 777 in other flights in my video channel. Thank you for watching this video. Tonight we're gonna be flying from Zurich International back to Zurich International, flight level 250 to 25,000 feet with Mach 0.82 or 340 knots. And right now I'm in the cockpit for the takeoff preparation, and I'm gonna make an explanation of some of the Airbus A340 313X systems, and maybe we're gonna make an engine start demonstration before takeoff. So this is the cockpit of the Airbus A340. As you can see, here I have the primary flight display over here with the horizontal situation indicator, attitude indicator, which displays the horizontal and the vertical guidance of the aircraft in terms of the side stick inputs, and also from the autopilot flight director, autopilot, and flight management computer commands. You can see here that I'm using this side stick, the Lszh String 3D, to move this surface, and it's also displayed here in this lower ECAM display. As you can see, when I move left or right, the ailerons and the spoilers needs wing. So you can see I'm moving the side stick. This moves also, and so when I move this up or down, I move the horizontal stabilizer elevator. You can see it's moving here in the display. And I'm also having the rudders here, the tail section rudder, and I'm using the pedals here to move this rudder, and I'm also using the side stick here, which is displayed over here in the, like in the original Airbus. This aircraft has a fly-by-wire system, which I will be explaining in another video, and it has 3 primary and 2 secondary flight control computers to manage the flight controls using normal, alternate, or direct flight control laws. So also in this primary flight display we also have the airspeed tape here with the speed selected, or manage the altitude, the barometric altitude above sea level, which is 1,430 feet above the sea right now, with the QNH of 29.92 inches of hydrargus. And here we have a compass that is also magnetic or true, and displays right now in the runway heading. We also have a radio altitude here, which is -1 feet right now. And here we have the flight mode annunciator for the auto thrust, the autopilot, horizontal and vertical guidance, the approach, and one flight director, 2, and the auto thrust. So if I'm gonna arm the auto thrust here in the flight control unit, which is the autopilot flight control unit, you can see the thrust idle, which is because I'm having the thrust levers right now in the idle tension. The thrust levers have an idle, a climb, a maximum continuous thrust, and a takeoff go-around detent for this aircraft, the Airbus. And it also has a reverse setting, which I use the thrust reverses like that. I'm gonna close them down right now. So if I'm gonna now this causes the auto thrust to disconnect when you move the thrust levers to the idle. So if I'm gonna move them in the takeoff go around, you can see the manual takeoff go around thrust displayed, and the thrust over here in the ECAM. Here is the N1, which is the low speed starter, low pressure starter speed, which is goes all the way to 98%, I think. It go above that. actually maybe 104%. Here is the exhaust gas temperature, the N2, which is the high compressor, high pressure compressor, high speed rotor speed, which is 67% right now. It goes down. The fuel flow 2320, 2280, 60, 40 is decreasing. Pounds per hour per engine. The fuel on board, which is 72,400 liters. The flap setting over here, I can use more flaps if I want. I've only this control lever here. I can move the flaps all the way up, all the way down. So maybe we're gonna make an engine start demonstration right now. So I'm gonna need to have a little bit more of time. So I'm gonna be faster with that. Here we have other systems besides in the lower ECAM. Besides the flight controls, we have the engine secondary display, which displays additional engine data. Fuel use, oil quantity, oil pounds per square inch, which is the oil pressure, the oil temperature, the vibration of the N1 fan, the vibration of the N2 fan stage, which is the low pressure compressor and the high pressure compressor. Like here, the low pressure, low speed compressor fan stage, which is 22% right now, 22.9, and the high pressure, high speed compressor stage, which is 60.2% right now. We also have a nozzle air temperature 144 degrees. Our gross weight here, I should manage this through the flight management computer later through here. I will input this data. So maybe we need to do a few additional things right now. Here you can see the overhead panel. Here we have the ADIs, the lights, the APU. I'm gonna turn the APU on in a while, which is the auxiliary power unit we're gonna use for starting the engines in the ground. This is going to provide compressed air and alternate current electricity to supply the system to start the engines. So this is the air supply, air bleed from the engines, engine 1, engine 2, engine 3 and engine 4, left wing engine and right wing engine, and connecting duct, which can be isolated using this switch over here. You can close it or open it, and this is useful for starting the engines, or you can leave it in the auto position. And there is the APU bleed, which is on right now, but there is no air because the APU is off. This is the pack which supplies with compressor, the cabin pressurization system, and the air conditioning system, and hydraulics pressurization manifold valves. But I'm gonna talk about this later. And here we have the fuel panel. We have maybe I should show you this view better. Here we have a better view of the cockpit. That's better. As you can see here, here is the air pressure panel, the electrical panel. I'm gonna show you a little bit with this. I'm gonna magnify the the ECAM display. So we have it a little bit more. A little bit more light, maybe. Yeah, it's better like that. So I hope you can see here in the ECAM display. This is the engine. This is the bleed from its engine right now, which is working. So if I'm gonna turn off the engines, there is gonna be no bleeder. The cabin pressurization system I'm gonna take later. The electric, the alternate current electric from generator 1 and 2 and generator 2 and 3, which is displayed as generator 1 and generator 2 for this simulation. The external B and external A, and the APU generator, which is off right now. There is no APU power. This is actually to the essential transformer rectifier, which supplies with direct current by converting through the transformer rectifier the alternating current, and supplies into the batteries and direct current and essential buses, like you can see here, tier 1, tier 2. Tier 1 supplies a DC battery bus through the contactors, and the alternate current also is the same through contactors for generator 1 and generator 2, 48%, 115 volt, 399 Hz alternating current, and the contactor are right now connected into the system to supply the buses and DC essential bus, DC1, DC2. And there is also a static inverter. We have no alternate current, so if I'm gonna turn off, you're gonna see here I can turn off the engine electrical power right now. You can see it's off. Now there is no electric from the engines, it's only from the batteries. I can turn off and the other two engines to make it more clear, because it's 4-engine aircraft. You can see here the messages displayed, the warnings. Electric DC bus 1 and 2 is full. Electric AC bus 2 is full, and AC bus 1 is full, the electrical. So you can see there is no displays here. Navigation display is gone, the secondary ECAM is gone, and the PFD only is working from the captain's side. First officer side is gone. And so I'm gonna turn on the APU right now to show you something, maybe turn the APU master and the start switch for the APU. So we're gonna make an engine start demonstration in a while, a couple of minutes. So here's the fuel panel, I'm gonna show you in a while. So I'm gonna reconnect the engines here. You can see the engines are connected, but the APU is still off. Hope you can see that. APU generator is 0, so it's gonna start increasing in a while. Maybe we have the APU here, in display. Here is starting up again. 60%, APU generator is 0 right now. APU bleed, this is for the compressor from the APU, and this is for the electrical from the APU. Now we have electric from the APU. Now I'm gonna show you here. So if I'm gonna turn off the generators from the engines now, I'm gonna keep having electric from the APU and the batteries. So this is it. Generator 1 and 2 is gone, but we have electric for systems from the APU. Through the generator is gone. Generator 1 and 2. So I'm gonna reconnect the generators. And here is the red cameras not removed. Turn off the IDG, the integrated drive generator contactors, because this is gonna need maintenance in the ground. We cannot reconnect them. This is the fuel panel, the fuel on board. Right here it's the left wing, the right wing, the inner and the outer tank, and the pumps, the primary pumps, one in its inner inner tank and left wing or right wing inner tank. The center tank with their own pumps, and the aft horizontal stabilizer trim tanks in the tail section of the plane. So I can use the X feed to show you what it's on. You can see the pumps here going on when I turn this this is open, displayed also here. Now is every engine can be fed by the X feed from any pump in any tank. This is for a case of failure actually, or fuel leak from a wing. So you can use the other tank, for instance, or fuel imbalance between the two wings. So I'm gonna turn this off. So if I'm gonna turn the pumps off, the primary, you can see the secondary stay on. If I'm gonna turn them all off, the engines will go off. So I'm gonna turn them on again and show you maybe the XFR. Now we have forward transfer from the trim tank, but we don't need that. So I'm gonna turn this off. I'm gonna talk to you about later. And here is the hydraulics. We have green hydraulic from engine 1 and engine 2. Yeah, here it's displayed in the lower icon. We have green hydraulic from engine 1 and engine 4. We have yellow hydraulic from engine number 3 and blue hydraulic from engine number 2. Each engine hydraulic pump generator also has an additional standby electrical, which can be activated manually or automatically in case of a failure of an engine or its on-site hydraulic power pump. And also we have some other, you can see here I can turn them off or on. The electrical, it's on right now. So you can see the message displayed here with yellow, it's off. So I'm gonna turn them on again. So you maybe later because we have to do an engine start right now. So I'm gonna get back to this. I'm gonna show you here the electric. So if I'm gonna turn off the engines, the generators are gonna be off. I'm gonna turn off the engines through the engine master switches, which supplies with fuel its engine by opening and closing the low and the high pressure fuel valves to admit fuel from the fuel tanks, fuel pumps, and also activates the FADEX that I'm going to talk to you about later. You can see here the engines are off right now. They're going into excess, and here is the electric power is also gone. The electric. So we have the APU now supplying with electric. You can see also here in the upper panel, the overhead panel, the same thing. Each generator from its engine right now, electrical, is having a fault message, and same is maybe for the hydraulics. I'm not sure. So the FADEX actually manages everything that you see right here in these displays. They're used for engine start and engine actuation during the service of the plane. So I'm gonna do this very fast. I'm gonna come maybe to this virtual cockpit to show you. I'm gonna turn this on, which is the engine mode selector. I'm gonna turn this in the ignition. It's pretty much the same for all Airbus aircraft. So this is what closes the packs here that I showed you before. So we're gonna do this also manually to show you what I need. I need to turn these packs off. APU bleed is on. We need this on right now. And this in the closed position, not the open. Which is the isolation valve between the left and the right wing engine bleeds for the pressurized air. This is gonna start the engine started, and this is gonna be the engine. Yeah, the electrical, we're in a good position right now to start the engines. This is all we need from the hydraulics. So you can see here the engines are off. It's no spinning right now from my other side. So I'm gonna come back here. You can see I'm gonna start the left wing engines first. So I'm gonna show you, here is the bleed I was telling you about. You can see there is no bleed there. The PSI is low from its engine, it's only from the APU. And this is gonna start the engines. So this is the engine display here, it's additional. You can see the red cross and 0 PSI for the hydraulic, for the oil pressure, and here the yellow X is for the engine high pressure compressor. So I'm gonna just start the engine master switch 1 in the start position. When the N2 is gonna reach like 20%, it's gonna to admit fuel from the fuel tanks. So you can see here is the engine number 2, the engine number 1 here. I'm gonna start immediately. Gonna start now the engine number 2. You can see the N1 and the N2. We need an N2 of about 20% to start the engine. You can see here the spinner has started doing some. You can see here the gas, the fumes are coming out. So I'm gonna start the other side engine now, but I'm gonna first need to turn off this on the auto. Leave this in the on APU. So I'm gonna use for the engine number 3. I'm gonna show you the other side. The right engine view. We'll start this engine right now. You can see here the temperature and the N2 and the N1 all increase, and the fuel flow from 0 to 1900, 2000 pounds right now. So I'm gonna do something here in the here the zero fuel weight. Yeah, we need 319,000 pounds. I'm gonna set the zero fuel weight and the center of gravity now, and the block fuel is 70, maybe 73,000 pounds right now. This is something we should do before starting all engines. This is gonna make a lot of calculations. Wait, 73, yeah, is a dollar. So 73,000 pounds, the block fuel, takeoff weight 391,000 pounds. This is gonna set our center of gravity at this position, 28.8%, 389,400. Yeah, we're in good position right now, so I'm gonna start with the last engine number 4. Now we start this engine that I'm gonna show you inside. You can see this block is when it's starting the FADEC. This gray block that displays the N2, that means the FADEC is initiating the engine, and also maybe the engine starter is on. So we're gonna start very fast now. Everything in the overhead panel is okay. So I'm gonna only start this section, the flight management and guidance computer, very fast. And departure and arrival airport, LS, SZH are departure and arrival airports, which is the same for this flight. Align the IRS, our flight level 250. Flight number, leave it blank. Flight plan from Zurich International, departure runway 14, 3000 meters long, using this standard instrument departure fixes. You can see them displayed here. So I'm gonna use maybe this mode, make this a little bit more well easily readable here. Maybe add some airports. I don't know. You can see the flight plan, which is a flight path, also in the airports around us. I can increase the range a lot, and that's gonna clutter the display. Enable cruise. So I'm gonna come down to the arrival airport, which is the same. Using the arrival page, select the ILS frequency and runway, which is runway 14, and our standard terminal arrival fixes. So I'm gonna clear the discontinuity here. We have no discontinuity and we are almost ready. I'm going only to fix this. This is the center of gravity trimmable horizontal situation, trimmable horizontal stabilizer in the tail section. I'm gonna set this at the 2 up for takeoff, 2 degrees up. You can see it also displayed here in the flight control. I'm using this side stick to input how much I want to make it, up or down. I'm gonna use for takeoff 2. So this is gonna be, with respect of the center of gravity, it's gonna give us flaps 2, 20 up. It's gonna give us our V speeds, our takeoff speeds. I'm gonna use flaps 2 and we're ready to take off almost. The V speeds here, maybe I'm gonna set them on my own. 145, 150 and 160. This is a heavy aircraft, so we need a lot of airspeed. So this is the primary flight display, the flight mode annunciator that I was telling you about. The heading of the flight control unit and autopilot, the flight director, the localizer. I'm gonna turn on the ILS. I'm gonna show you now. So we have 25 minutes to go for this flight, so I'm gonna use make it very fast. So I'm gonna use more altitude here. So the heading should be selected right now, but it's no problem. So I'm gonna close a little bit this gap so you have better display of the takeoff, navigation display and primary flight display with the ILS frequency tuned here. So we're ready for takeoff right now. This is the Airbus A340 300. Here we are. I'm gonna start the takeoff roll now. I'm only need to move the thrust lever so the way to takeoff go around. And disconnect the parking brakes. You can see here the display's changed. So some messages here, some modes that are armed for the takeoff. Here we have V1, VR and V2. We take off. I retracted the landing gear, as you can see. Keep gliding. We're in a very good position. Now you can see the engine thrust is 93.7%. You can use this for 10 minutes actually. So much thrust. So you can see here my airspeed. I'm gonna talk to you about this. This is the radio altitude, which is 1950, 2,000 feet above the ground that you see below. Now it's 2,500 that is gone. And this is the barometric altitude, 4,200 feet above the sea level. And this is the rate of climb of the aircraft, which is 3,500, 400, 300 feet right now. It's quite high, so I'm going to decrease this a little bit. So this is the stall speed. We should avoid this yellow display here in the airspeed. My airspeed is quite low right now. Should decrease the rate of climb. This is the lever glide message. As you move in the climb, then right now. We can do this a little bit later. So now is the Mach takeoff, go on, MCT and glide. You can see the glide, thrust glide right now displayed here for the auto thrust system. This is the autopilot modes, the glide and the nav, and the altitude hold, which I have right now. Altitude selected 35,300. And this, when I press in these buttons, the modes are selected. When I pull them all out, the modes are selected by the pilot. When I press them in, they are managed from the flight management computer here and the autopilot. So here we keep climbing. Maybe make a right turn now. I'm gonna show you an outside view of this aircraft. So we have another 21 minutes to go for this flight. Took me a lot of time to finish talking inside about the aircraft system. You can see the runway here, the airport. So let's turn to the right right now. Maybe accelerate a bit by stop climbing. This is the fly-by-wire that I was telling you, using the side stick, which orders the primary flight computers to move the control surfaces. But the primary flight computers are trying to manage the flight by holding at zero load requests and limits. It's quite complicated. I have to read a little bit and explain it. So we keep climbing here. I hope we're gonna finish right on time. 55 minutes for this video. We're at 36 minutes right now. So maybe use a little bit more thrust, like MCT, would be a good idea. Because it's a little bit heavier craft. So it needs a little bit more thrust to climb out in the point that I want. Let's see how I move this. So this plate here. We're in a good position. Our first waypoint is 4 nautical miles away from us. The airspeed right now is 160 knots. It's increasing. Our rate of climb is 1,300 feet per minute. And our barometric altitude above sea level is 11,360 feet. And here you can see the upper limit for the airspeed because I have the flaps extended right now. I'm going to decrease the flaps maybe, so we're going to have more margin for airspeed. And this is the manage from the autopilot and the flight management and guidance computer. This displayed in purple, it's the manage speed, 298 knots. It's quite high, it's okay for this flight. Maybe I can use it higher, like 340 knots. You can see the auto trim here for the tail section of the aircraft, the horizontal stabilizer. Flaps 1 and plus maybe. Here 17 more minutes to go for this flight, so we are late. Maybe we won't reach our maximum climb out altitude. Who knows? You can see the 4 engines of the aircraft. I'll show you the other side. We need a little bit more rate of climb, a little bit more airspeed right now, but I'm using MCT. It's 91%. Yeah, I can use takeoff go run for a little more. This is very heavy aircraft, so we need a little bit more thrust. You can see I can move this in the takeoff go around position. You can see here the modes, the flight mode annunciator, max manual takeoff go around. I can use it for 10 minutes. Continuously climb, nav, altitude, one flight director, and auto thrust is in blue. so it's arm, it's not engaged. Our magnetic or true compass, our ILS frequency for the runway, which is 24.6 nautical 24.8 nautical miles away, 25 right now from the airport. Our altitude is 17,700 feet above mean sea level, barometric. QNH 29.92, and here we can see our bank and pitch angle and the limits. So I'm gonna turn this a little bit to the right to bring it back into the flight path. So we have another 14 minutes for this flight. Maybe we won't gonna make it in terms of what I want to do. Maybe we have to start turning now back into the airport. We have a good rate of climb, so in a couple of minutes we're gonna have reach our altitude. So we're gonna have our chemtrails. So we have another 13 minutes for this flight. We have to start descending in a while. So I'm gonna make the turn back into the airport while climbing out. We still need a little bit more to go. 13 minutes. Minutes. So in a couple of minutes we're gonna have our contrails, and we're very close for landing. I'm gonna start descending immediately. And here they are, the chemtrails that I was telling you about. You can see this magnificent effect. It's gorgeous. So we're gonna start descending in a while. So I'm gonna use this. You can see the star sign now. Have some stars, and I'm gonna use a direct 2 into the next, into the first. Yeah. We are 32.3 nautical miles away from the airport. So, and we have 10 minutes to go. So maybe we won't climb to 25,000 feet this time. I'll just have to return back into the airport. Here we are, 25,000 feet. Here we are. You can see the modes, the altitude hold mode right now. So I'm gonna start descending now. Use idle and decrease the altitude here to 7,000 for landing. So I'm gonna increase the airspeed a little bit. Only have 9 minutes to go for this landing, so we have to be fast. Let me make a shortcut for landing. And maybe overspeed the aircraft a little bit. Using speed brakes. We have 3 and 5, 8 minutes to go for landing. So I have to overspeed and make a few shortcuts again. You can see the thrust here is set by me. It's in the manual mode. We're reaching our airport. Closing in. So we have 8 more minutes to go. 7 more minutes. You can see the airport in a while here. And the runway. You can see the speed brakes here are extended. Increase a little bit the airspeed. So here it is, 6 minutes to go, so we have to land very fast. Here is the runway I was telling you. I'm gonna make a fighter approach again, like an F-16. Have to get lower and here is the runway we're gonna use to land. So maybe turn a little bit here. We need 5 more minutes to go. Keep descending. So we have it here, the localizer I'm gonna use. Here we have it. So we only need the landing gear. This is gonna be extended. We are at 4,000 feet, 2,000 feet above the ground, so we are in a good position to land. You can see the runway. So You can see the landing gear here is extended. We have 4 more minutes to go, so let's make this a little bit faster. Here we are, in a very good position to land. I'm gonna use full flaps, a little bit more airspeed, stabilize with the runway heading. We have 3 more minutes to go, so I believe we're gonna make it. – 1,000 feet. We have 2 more minutes to go. $500. 2 more minutes to go. So here we are. We made it. 400. 300. 2 more minutes to go. 200. 150. 40. 35. Here we are. Safely landed, as you can see. You can see all the wheels and the landing gear and the nose wheel are safe. There is no damage in the nose wheel or the landing gear. So this was very good landing, as you can see. So you can see the systems here, the reverse thrust. So we have 1 more minute to go. You can see the thrust reverses here from the engines in extended. So I'm gonna turn them off right now. So that was Thomas the pilot flying the Airbus A340 300 in this flight. I'm also flying the Boeing 737 800 and the Airbus A320 and the Boeing 777 and the Airbus A330 in another flight. So it was a pleasure to me to see you in this flight. I hope I'm gonna see you in another flight. Thank you for joining me. Bye bye. See you next time. Bye bye. I also did an engine start and system explanation while in pre-takeoff and while in flight, so I'm gonna come back with another video later explaining more about these aircraft systems. I need to read a little bit more the flight crew operation manuals, so thank you for